Here we will do a proof about linear independence. So let's say we have the functions f1 of x equals e to the negative alpha 1x, if 2 of x is equal to e to the negative alpha 2x, and so on until fn of x equals e to the negative alpha nx. And you know that alpha 1 is greater than alpha 2 is greater than until alpha n, which is greater than or equal to 0. We need to show that these functions are linear independent. Here we'll use a trick. We will look what happens if x tends to infinity. Okay. So to show linear independence, you have to show that you have some combination beta 1 of f1 of x plus beta 2 f2 of x until beta n fn from x. We need to set that equal to 0, and we need to show that beta 1 equals beta 2 equals until beta n, and that is equal to 0. So how do we do that? Well, let's just rewrite. Beta 1 times f1 of x is e to the negative alpha 1x plus and so on until beta n times e to the negative alpha nx. Sorry. And that should be equal to 0. What will we do? We will divide by e to the negative alpha nx. Okay, so we will get beta 1 times e to the negative alpha 1 minus alpha n times x plus beta 2 e to the negative alpha 2 minus alpha n times x plus and so on plus beta n equals 0. Now, what happens when x tends toward infinity? We know that alpha 1 is greater than alpha 2, it's greater than alpha n, it's greater than or equal to 0. So, this expression here, because alpha 1 is greater than alpha n, it will be greater than 0, this thing. Okay? And because there is a negative sign before, it will be 1 over e to the something times x. Okay? Here there will be the same thing. So if x tends towards 0, basically we will get zeros everywhere, because you will get beta 1 times something that is really close to 0 plus beta 2 times something that is really close to 0, and so on, plus beta n equals 0. So we'll get 0 plus 0 plus beta n equals 0. And so you get beta n is equal to 0. And then you can do that again for beta n minus 1 to beta 2. Now we know that beta n is equal to 0. Then you will show that beta n minus 1 is equal to 0, beta n minus 2, and so on until beta 2. And then you will only be left with beta 1 times e to the negative alpha 1x equals 0. We know that e will never be 0. It will be close to 0, but never really. and so you will get that beta 1 is also 0. Okay, and so you can show that beta 1 is equal to beta 2 is equal to beta n is equal to 0. And so the functions f I from x equal to e negative alpha I x, they are in fact, they are linear independent. Okay, so you need to, what you have to do if you want to prove that something is linear independent, two things are linear independent. You need to set it equal to 0, and you have to show that some combination, if you have some combination b1 of the first, let's say here function, plus some combination b2 times the second function, if that is equal to 0, that implies that beta 1 equals beta 2 equals beta n, if you have n functions, equals 0. Okay? Thanks for watching.